Hi everyone, welcome back to Math Lines. Our learning target for this video is I can solve exponential logarithmic functions using natural logarithms. Now let's take a look at some vocabulary. Natural logarithm. A logarithm with base e, written as ln of x is equal to log base e of x. Euler's number. A special irrational constant, e, is approximately 2.71828. Now we have this inverse relationship. E to the power of ln x is equal to x. This is the inverse of ln of e to the power of x is equal to x. These are equivalent equations because natural logarithms and exponential functions are inverses of one another. Now let's take a look at the problem of the day. Solve the following exponential equations by taking the natural log on both sides. Round all answers to the nearest hundredth. Part A, 3 to the power of t is equal to 6. So we are starting off taking the natural log on both sides. So we have ln of 3 to the power of t is equal to ln of 6. We're going to be using our power property to move our exponent to the front of our natural log. We now have t ln 3 is equal to ln 6. We want to isolate our variable, so we will be dividing on both sides by ln of 3. We are now left with t is equal to ln 6 divided by ln 3. And this is approximately 1.63. Now let's take a look at part B. 3 to the power of t plus 10 is equal to 6. Before we find the natural log on both sides, let's combine like terms. We're going to subtract 10 on both sides, and we now have the equation 3 to the power of t is equal to negative 4. We're now going to find the natural log of both sides. We have ln 3 to the power of t is equal to ln of negative 4. So we cannot find the natural log of a negative number. And for that reason, we have no real solution. Now that's it for this video. We'll see you in the next one.